This is Dr. Chiranjeevi Manike, Professor in Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad, as part of Deep Learning video lecture series. And in this lecture, I am going to explain about forward propagation and backward propagation, that is also called as a back propagation. So in this, I am going to explain about what do you mean by this forward propagation and mainly the backward propagation. There we discuss some mathematical concept that those are required to understand some mathematics part. So let us try to understand what do you mean by this forward propagation. Though I just gave some brief idea about this, what is a forward propagation, while explaining about basic building block of artificial neural network, that is perceptron, how the information is propagated from input layer all the way up to the output layer, and then how the error would be measured, and then how the retraining in the sense like adjusting the weights and biases, that is called as a parameter tuning, is done. So now we are going to discuss in detail like how and how what is the mathematical like what kind of information will be passed from one layer to the another layer, and how what are the gradients and how the gradients would be calculated. Like all these concepts will be discussed in a little in detail in this lecture. So let us quickly go back to this. Let us and this is a basic building block of a artificial neural network, that is perceptron, that we discussed in the previous lectures. So here from this you can see, because and to understand the subsequent concepts and some little bit mathematics, and we need to recall this, that's why. So here from this you can understand there are inputs, let us say like x1, x2 and so on, xn inputs that is we have in this, and there is a term called as a bias. So we discussed what is a bias. Bias is mainly to shift the activation function mainly used. So here these inputs, and here we have the weighted sum, that is aggregate function here. So what this information, how this information would be aggregated, like from all the inputs and the biases, and this information would be aggregated, and it also will have the bias weights like w1, w2 and so on, wn. So then this weighted sum, that is sigma I equal to 1 to n, because there are n inputs, and the wi times xi, that is each input is multiplied with the respective weights and sum together. So this is aggregated sum, that is weighted sum, and then the bias also would be added. So this is the operation that is done, and this, because that we will discuss like mainly this is one operation. Any neuron, or we can say a neuron, will be in the two states, like activation and the pre-activation states, that we will discuss in a couple of minutes. So this is the how this weighted sum, and then we have to find out the weighted sum and then add the bias term bias, and then give it to this activation function. This is a non-linear activation function. So there are like popular activation functions, popular activation functions like sigmoid, tan h hyperbolic function, and ReLU, softmax. So these are the four popular nonlinear activation functions. So this would be passed to a nonlinear activation function. So here this G is a nonlinear activation function. So then it produces the output, that is y hat. Okay, so let us just quickly recall what it happens, how the information like aggregated and passed to the activation function, how the activation function will produce the output. So there are like, based on the problem, there will be like the set of inputs and the respective outputs, the weights also, because the each input would be given a different weight. Okay, because all the features may not be important in the real world, so each feature will be given a separate weight. So that's why w1, w2 and so on, wn, the respective weights. So the input and the corresponding respective weights would be multiplied, that is weighted, then we sum together, that is weighted sum, and then we'll add the bias term, that is a constant, that we will discuss why we need to introduce and how it is going to play the significant role, that will be discussed in the coming lectures. So, and then this would be passed to the nonlinear activation function. So the nonlinear activation function, like suppose these are some popular nonlinear activation function. If you would pass this information, this is this one, to the nonlinear activation function, then it produce the output. So that means when it produce, like suppose as we discussed in the previous lectures, like we mainly discussed the step function. So that a step function would return always either 0 or 1. Okay, based on the threshold, like suppose as we discuss f of z, like a function would return 1 if z is greater than or equal to 1, else less than 1. Okay, g is less than 1, like that. If you would have defined the function and the threshold value like that, and then it would gives the output. So then the information is, that is, this is the output that is predicted. So now we have to calculate whether our model is classified accurately or not, so correctly classified it or not. So to find out, we have to compare the actual output and this y hat is a predicted output. So, and that like that will be calculated, that is error, or we also call it as a loss function. We use a loss function to find out this error. So then we like whatever the error we have, and that error need to be minimized, because then only our model would able to predict or classify the data or the samples more accurately. So in order to minimize that error, so we have to, that error information need to be propagated back, that is from our output layer all the way up down to this input layer, so that the weights and biases values would be adjusted, and then we retrain the model so that it again will check the loss function, that is error, is there any error or not. That means if our model is would able to classify the samples correctly or not. So that is how the information is propagated from input layer to the all the way up to the output layer, and how the error would be calculated, though we will discuss all this in detail. Okay, no need to worry about it. This is just a quick overview of how the information is processed from input layer, from one layer to another layer, output layer, and how the error would be measured. All these concepts will be discussed later. So this is how the information is propagated. So this is called as a forward propagation, and I think this I can skip. Yeah, so next another thing is the backward propagation. As I said, the error, like if the predicted value, like suppose this is actual value, y is a actual value and y hat is a predicted value, so then we have to, there is a difference, so that means there is a error. Let us say error is represented with a term e. So this need to be minimized. How do we minimize this? And so that is by propagating the back that error information, that is from output layer to all the way down to this input layer. How this error information would be propagated? Because, and mainly, like we cannot just simply like what do you mean by this propagating this error information? How do we propagate it, and what changes we will make that is to train them to learn the model more effectively, or to classify the data points of the samples more accurately. So that we will discuss here. So this model is produced, right? There is some error. That means the model is not able to predict accurately. So that means if y is not equal to y hat, that means output is not matching with the target. The predicted output is not matching with the target. So how do we train the model? That is very, very important here. So before, let us again just quickly understand, like suppose if you take this example as a simple artificial neural network with the two inputs, and there are weights W1, W2, W4, and this is bias, let us say B1 and B2, and similarly, and this each neuron in this, because these are the input layers, the only receives the features, and this hidden layer, and this is a one hidden layer this artificial neural network have. So this each neuron would be divided mainly into the two states, like those are like activation state and pre-activation state. Pre-activation and then activation. Pre-activation. So that means before, like suppose here, let us say this pre-activation was represented as AI, and activation is represented with the HI. And similarly, and this also would be divided into two parts, like let us give H1, A1, H1, A1, H1, A2, H2, and similarly this also will have activation and pre-activation, and this W5 and W6. Okay, so now let us try to understand what is this A1, A2, H1, H2. I think it is not very difficult. So let us try to understand what is this A1 here. So A1 is, that is pre-activation. That means, so like just now we discussed about the basic building block, how the information, that is how the inputs are multiplied and summed together and added the bias term and passed to the activation function. The same if you would apply this, so then that is before the activation function. So what is the equation? How we calculate the values? So that need to be understood. So here this A1 is influenced by like X1, W1, X1, plus it also receives the input from the X2, that is W2, X2, and then bias term B1. Okay, so bias term B1. So that is a pre-activation of this neuron. This is neuron. So similarly, A2, if you take A2 receives the input, that is X1 with the weight W2, and another input X2 with the weight W4. So then W2 X1 plus W4 X2 and the bias B1. Okay, so now, and these are the A1 and the A2, that is pre-activation. Before we pass this to this, how the information would look like, that is before we pass to the activation function. So once we pass this activation function, let us say like suppose A1, if you take this neuron, So then H1. So H1 is nothing but G of A1, where G is a activation function. Where G is a activation function here. Okay. So similarly, H2 also. H2, that is G of A2, and similarly A3, like suppose if you write A3, so A3 is receiving what information is received, right, from the previous neurons in the previous layer. So there are two neurons in the previous layer, that is hidden layer, only one hidden layer in this network. So then the A3 equal to, so W5 times I would write like H1 plus W6 times H2, and then bias B2. Okay, so this is the information that is received from the inputs and the corresponding weights and then bias term at this neuron, output neuron, that is only one neuron in this output layer. So then the H of 3, that is obviously G of A3. So that means, and this is a pre-activation, means the information that is before we pass to this activation function, and the pre-activation means after passing to this activation function, then that is the information. So now, because I just want you to understand how the input layers and the next layers, because they're all connected, and how the information is flows through from input, that is from input layer all the way up to the output layer. So then, because then only we'll understand how or what adjustments need to be done, that is in the backward propagation, that is to retrain the model to accurately classify or to perfectly classify all the samples in the data set. So in this case, okay, so suppose if you take one simple A3, how the A3 would be, or H3. So H3, that would be expressed as G of H3 would be expressed as G of A3. Okay, A3, and then what is A3 here? So A3 is, as we already, okay, so H3 would be represented, that is in the form of like H1, A1, X1, like that. So then there is a relationship, that means that is mainly, and if you observe this H3, that is the output of activation function in this output neuron. So this output is depends on A3, and the A3 is influenced by mainly the 3 here, that is H1, H2, and then W5, W6, and also B2. Okay, and even if you take this H1, like, because I just want you to understand, if you come the backward direction, like which variable, because this is output which is produced by the output layer, that is in a neuron in the output layer, and if there is an error, then how the adjustments need to be done. Adjustments means we cannot just randomly go and adjust the weights and biases. So because we cannot, like, suppose we have to know the amount, like suppose if the weight and if the bias, what amount or what rate of change or what change need to be done, in which direction also. So like what are the inputs, and what are the weights and biases need to be updated. So that need to be understood. So that means we have to understand what is the contribution of each parameter in this error. So if you are able to understand the contribution of each parameter in this error that leads to this error, then by So if you understand that, so that we can make the adjustments. So as I said, it is not just like a random process. So here we have to follow the approach, that is by applying the chain rule, like this is mainly implemented, like how the weights need to be updated in the backward propagation, right? So that we can retrain the model. So this is mainly built the process based on this chain rule. Like suppose y is equal to f of u and u is equal to f of x. So then the derivative, that is a rate of change of y, the function, that is a rate of change with respect to the x, and that would be calculated by finding the derivatives. So like dou y by dou x equal to dou y by dou u times by dou x. This is a chain rule in calculus that is used, right? So that means if you want to change the output, and we have to understand and what are the parameters influenced or connected. Like suppose here you can see, let us take just a quick example, simple, that is to understand here. Like H3, if you take H3, and that is depends on, because the A3 is the input or the information that is passed to the activation function in this layer, then we got a H3. So that means H3 is, let us take like H3, that is depends on A3. Okay, and then A3 is again depends on, A3 is depends on what are the influencing parameters of this A3 here, bias, W5 and W6. Again if you go back, and W5, so one more thing is H1 and H2 also. Okay, so H1, H2, I would write like H1, H2, and then H1 is influenced by A1, and again in this, if you go in this direction, so H2 is influenced by A2, and again A1 is influenced by, or A1 or A2 is influenced by, A2 influenced by the weights W2 and W4 and the bias. Okay, that is W2, W4 and bias. So these are the contributing, right? So this is the way, that is if you want to find out like what adjustment, how amount of adjustment or this weight W2 need to be updated. So we have to, that is with respect to this error, total error. That means we calculate the error, then what is the contribution of W2, that is weight 2, and similarly what is the contribution of W4 or other parameters like weights and biases in this. So how do we find out that? How? Because in the real world, this artificial neural networks are more complex. That means the number of inputs in an input layer, and also the number of hidden layers and output, and there's many millions and billions of parameters would be there in a complex artificial neural networks. So how this weights, that is how much and what direction and what updates need to be done, so that we expect our model to predict, or we'll give that we train the model to accurately predict the samples or data points. So that means the amount of the change, that is to understand the further concepts. So we have to recall few basic mathematical concepts which very much essential to understand. So let us see what are those concepts we need to recall. So the one thing is a derivative. So that is the rate of change in an equation at a specific instant. Because like we cannot just make a constant change, and right. So what amount of change need to be done? That is how we can tune so that the input and the outputs are matching. That means a predicted output should match with the actual output. So how the tuning would be done? So that is the rate of change in an equation at a specific instant. So to understand a little bit more, so let us take like suppose an equation, a line. If you take this a straight line, and this is x and this is y, and if you take any that is instant, a specific instant means any segment of line, like suppose this, if you take this points, and this is delta x and this is the delta y, that is a rate of change in x and a corresponding rate of change in y or vice versa. So here the slope, that is delta y by delta x, that is a rate of change. Like suppose this is a straight line, so that if you take any instant, like suppose if you take another part, and here also the rate of change, that is delta x delta y, that is delta y by delta x, remains constant. Okay, but whereas if you take non-linear, it is a linearly separable. If you take a non-linear, let us take, yeah, so let us take one line, one curve like this. So now, and if you take any instant, like any two data points, and if you observe what is the slope, rate of change, and that varies. Like suppose here if you take this one and this one, and this, the rate of change is different. So that is that's why like so because if it is a constant rate, like in the previous step, if you have a line equation, the slope remains constant, but here this rate of change is not a constant. So that is the thing you need to understand. So a derivative is the rate of change in an equation at a specific instant. So next, the differentiation, that is the process of finding derivative of a specific function. Like suppose if you take a function which is f of x comma y, that is equal to x square plus 3x square, a specific function, then we have to find out the derivatives of this function. So by differentiating a non-linear function, we can then find the slope, that is its instantaneous rate of change at any specific point in the curve. If it is a straight line, the rate of change remains constant. So whereas the line is like a curve shape, then the rate of change would vary from one instant, from one point to another point. Okay, so this we need to understand. Okay, so by using this differentiations, and we'll find out this, the rate of that is non-linear function. This is a non-linear function, so we can find its slope, that is a instantaneous rate of change. So in functions with multiple variables, a partial derivative is the derivative of one variable concerning the others. Like suppose f of x comma y is a function, that is x square plus 3y square. So the derivatives to this, like df by d, that is with respect to x, and also with respect to y, that equal to 2x, and here it is equal to 6y. So these are the derivatives, that is delta x and delta y. So if we change the one variable but keep the others the same, how does the output of the overall function changes? So these are all we will understand with this derivatives. So next one is activation function of individual nodes in a neural network have many variables. Like in the previous example that we discussed, there are variables like weight, the only two weights. If you take each neuron in the hidden layer, there are two neurons in the hidden layer. So the variables are like weights, biases, inputs, etc. These are all will be there. That is like including the many inputs from the neurons in the previous layers and weights applied to those inputs. So these are all the variables. Next one is a gradient. A gradient is a vector containing all the partial derivatives of a function. Like suppose this f of x comma y, that is x square plus 3y square, and the derivative of this is delta x comma delta y, that is equal to 2x 6y, right? So it's a vector containing all the partial derivatives of a function with multiple variables. So it is essentially represents all the factors affecting the rate at which the output of a complex equation will change following a change in the input. Next, as I said, chain rule. It is a formula for calculating the derivatives of the function that involve not just multiple variables but multiple functions. For example, consider a composite function like f of x equal to a of b of x. Then the derivative of the composite function f is equal to the derivative of the outer function a multiplied by the derivative of the inner function b. So what is the main goal of this back propagation? And if you look at the goal of this back propagation, that is mainly to calculate the gradient of the loss function. That is what adjustments need to be done, right? So the gradient of the loss function, that is with respect to each of the individual parameters of the neural network, with respect to weights, with respect to the biases, etc. In simple terms, back propagation uses the chain rule to calculate the rate at which loss changes in response to any change to a specific weight in the network. Like as we discussed, what are the parameters contributing that particular error, and if you that the chain need to be identified so that the adjustment would be done. Because it's a fundamental course, I'm not going to discuss in the more mathematical parts, and that will be discussed in the next version of this deep learning course, like more complex mathematics and all would be discussed. So the training neural networks with the back propagation entails mainly the following steps. As we already discussed, let us just have a quick recap, like a forward pass, that is making predictions on the training data, loss function that measures the error of the model's predictions during the forward pass, and this is what we are discussing now, back propagation of error or backward pass, to calculate the partial derivative of the loss function. Like suppose if there are like n by n, right, the dimensions, then we have to find out all the derivatives. That means the rate of change, like each variable, like suppose the previous example w1 w2 like w5 6, so each what change need to be done. Okay, so accordingly we'll retrain the model. Next one is a gradient descent, that is to update model weights. So let us quickly summarize what we discussed in this lecture. Here mainly we discussed about one concept, that is forward propagation. And second, another important concept, that is backward propagation or back propagation. So in this back propagation, we mainly discussed how the back propagation would be done. That is in a theoretical aspect. And mainly we discussed a few basic mathematics. Mathematics that need to be recalled to understand the concept like derivatives and partial derivatives and gradients, etc. So next lecture we will be going to discuss mainly, that is little deeper, like how the gradients would be calculated and how the gradients are used to update this, that is by using a gradient descent algorithms, how the weights and would be updated, that is to improve the accuracy of a model. So thank you for watching this video.